Hi everyone, today we're going to be talking about topic 7.5, magnitude of the equilibrium constant. So I had previously shown for this generic equation here, if I have m moles of reactant A reacting with n moles of reactant B, and those are under equilibrium to form x moles of product C plus y moles of product D, the equilibrium constant, we'll say in terms of concentration K, or of course this is the reaction quotient if you are not at equilibrium, is equal to the concentration of products over reactants. Concentration of C raised to the x times the concentration of D raised to the y divided by the concentration of A raised to the m times the concentration of B raised to the n. And so we can basically think of this as a ratio of products to reactants. And when we do this ratio, this tells us the equilibrium constant K, doesn't really matter if it's Kp or Kc or whatever kind of equilibrium constant. Basically what it tells you is which way the reaction prefers to proceed. And so I've said here, right, that at equilibrium, the rate of the forward reaction, right, so at equilibrium, the rate of the forward reaction equals the rate of the reverse. Or you have unchanging concentrations, and as the forward reaction is happening in this direction, that's equal to this reaction going backwards. But this does not tell you anything about the concentration, and so that's where K comes in. So let's take these few examples here. Let's say K is much, much lower than 1, right? And if I'm going to say a specific number, if it is less than or equal to 0.001. If you do the math out and K is less than or equal to 0.001, the reaction barely proceeds forward. In other words, let's say I have A in equilibrium with B, or a reaction of A going to B. What that's basically saying, let me erase this arrow here, what that's basically saying is this arrow going forward is very small, but this arrow going backwards is very big. The reaction basically doesn't happen if K is much, much less than 1 or less than or equal to 0.01. Now let's take the case of K is just less than 1, but not extremely small. In that case, it would be between 0.001 and 1. Right? It's smaller than 1, but it's not necessarily extremely small. This means that the reaction prefers reactants. And so again, in my case of A and B, what this basically says is this forward arrow is small. It's not extremely small like the last case, but it's smaller than the reverse. Right, the reaction would rather go backwards overall than go forwards. And so in this case up here, right, this reaction, I'll do this in a green arrow, this reaction wants to go back. In this case, again, the reaction wants to go back, but it's just not as profound as that first example. Now you can imagine we have two scenarios in the that are exactly opposite. And so that's favoring the reverse. Now we have favoring the forward. If K is greater than 1, basically if it's between 1 and 1,000, the reaction prefers products. So again, in our scenario of A transforming into B, what this says is this top arrow is going to be larger than this bottom one, but not extremely large, and the reaction prefers to go forward. The last scenario, of course, is if K is significantly greater than 1. And similar to the previous case, this is basically greater than or equal to 1,000. Right? If your equilibrium constant is greater than or equal to 1,000, the reaction basically goes to completion. Doesn't actually necessarily go all the way to completion, but it's basically at completion. So if we have A going to B, this top arrow is going to be quite large, and we have a tiny little arrow going in the opposite direction. And of course, the entire reaction prefers to go to the right. And so by looking at what the number of K is, remember K is always going to be positive. K is always positive. But by simply looking at the number that you get after doing that calculation, that'll tell you whether or not the reaction wants to go towards the products or towards the reactants. Or in other words, which one will have the higher concentration at equilibrium. We got to be really careful. Always remember, it's products over reactants. If you do it the opposite way, then it'll look like you have the opposite result. So let's look at this one AP problem together. And so what we have here are two reactions, 1 and 2. In the first one, we have Br2 plus Cl2 makes 2BrCl, and that has an equilibrium constant of 10. Keep in mind that this is greater than 1. In the second reaction, we have N2 plus O2 makes 2NO. And this is our equilibrium constant, 4.2 times 10 to the negative 31. If we look, this is significantly smaller than 1. So now if we read the table, read the question. It says the table shows the data for two reactions carried out in two separate containers, both at 1 liter and both at 298 Kelvin. To each container, they add 0.5 mole of the appropriate reagents, and they allow them to reach equilibrium. And so it says, based on this information, which of these correctly compares the relative concentrations of this, of 2BrCl and 2NO. And so essentially, we're thinking about what is the concentration of 2NO versus the concentration of BrCl in these two different reactions. So A says that they're equal because equimolar mixtures of the reactants were allowed to reach equilibrium at the same constant temperature. But remember that equilibrium tells us nothing about the actual concentration. And so this one can't be true because we don't actually know anything about their final concentration necessarily because they're at equilibrium. And so A can't be true. This one says BrCl is greater than NO because Br2 and Cl2 are larger molecules that can collide more frequently to form products. Remember that the direction of a reaction doesn't necessarily have anything to do with the size of the molecules. Collisions, of course, are happening, but the fact that it's a larger molecule has nothing to do with the fact that this reaction wants to go forward. And so B also can't be the correct answer. If we look at D, this says that BrCl should have a lower concentration than NO because the much larger K for reaction 1 means that hardly any products will be formed. But remember, if it's greater than 1, it prefers products. So this can't be true because what it's saying is that because it's greater than 1, it prefers the reactants, although that is backwards to the logic that we know, so D can't be the right answer. The only correct answer here is C. The BrCl, the concentration of BrCl is going to be greater than the concentration of NO because this equilibrium constant is greater than 1, which means it prefers products. Whereas for this reaction, because it's so small, it basically won't happen. If you mix these two in a container, you'll basically just have nitrogen and oxygen gas floating around with hardly any, if really any, 2NO at all being produced. We'll do some more practice in class, but for now, that's all. Thanks, guys.